Hi, I'm Liz, and I'm a developer advocate at Honeycomb. And today I want to share with you some of the lessons that I've learned from over 15 years of being in an operational role. So this is something that is going to save you a lot of time and energy and 2 a.m. late nights. So what I want to teach you today is the idea that our systems are always failing in microscopic ways, and that we only care if real users are being impacted too badly. Does it really matter if CPU on one server is wedged at 90%, if it's 2 a.m. and no one's actually hitting that server? So our systems are always failing in microscopic ways, so instead we need to embrace that. We need to measure what we do if users are experiencing too much brokenness, but otherwise we can just stand back and get a quiet night's sleep. So this is a concept that I learned as a site reliability engineer, that we need to adopt service level indicators in order to help measure what reliability is to our customers, to our product management, to our dev teams, and to us as operators. We have to quantify whether critical user journeys are working correctly, whether our customers are able to successfully access our services, and if not, what's going on and how we can remediate. This means we need things like build ID, amount of time that requests took, and information about which customer is impacted. And we need to be able to categorize these things as good or bad. We need to be able to figure out what makes for a good or bad user experience. And yes, that involves thinking about things from a product manager's perspective. We shouldn't be aiming for 100% reliability or for 1 nanosecond of time for a request to elapse. We need to actually set realistic expectations. And sometimes we can do that by chaos engineering, by slowing things down by a little bit and seeing what happens. We need to come up with a threshold that buckets events into good and bad, and then from there we can measure the quality of user experiences. So for instance, we might want HTTP code 200 or latency less than 100 milliseconds to define a good request. And that's what that might look like from one of our own applications. And then we can figure out what our goal is. How many eligible events did we see? What's the denominator of that fraction? For instance, we might want to exclude botnet traffic or internal load checks. So after we've defined the parameters for what's eligible and what's good, we can then go ahead and define what the target availability is, and think about what our target service level objective is. And once we define this, it gives us a guiding light as to what a good level of reliability is that we should be aiming for, and that we won't wind up waking people up if there's a failure that's smaller than that. So we need a window and a target percentage. We don't want to be constantly flapping on, oh my god, it looks like we're going to run out of our error budget for today. Our error budgets can last over longer periods of time, like an entire month. So we might aim for 99.9% of events to be good over a 30-day window. So in the course of doing this, we're not aiming for 100%. We're not aiming for 1 nanosecond, right? We're trying to barely keep our users happy, so that we as operators can get a good night's sleep, and so that our customers can have their expectations met when they're most using the service. After all, many users are using cell phones or using home internet connections. It doesn't really matter if we have an industrial grade 99.99999% available service if our customers are still experiencing pain downstream. So we need to make sure we maximize product velocity. And that means that we need to slow down only if we're causing too many problems for our customers and they're noticing. So instead of alerting on every time the disk gets above 90% or the CPU gets above 90%, we instead need to think about alerting when we're in danger of exhausting our service level objective. So that means that we have an error budget, which is the amount of allowed and availability. Yes, I know this takes a little bit of wrapping your head around, but I promise you it's worth it. So if I have 1 million requests per month, and I have a 99.9% target service level objective, that means I'm allowed to fail 1,000 requests per month. So if I'm burning through 100 of them per hour, I'm going to run in 10 hours, I better get woken up. But otherwise, I can sleep through the night. I can look at it the next business day. It's okay if I'm going to exhaust my error budget in a matter of a week rather than exhausting my error budget in a matter of hours. So this is a real incident that we had at Honeycomb. It's one of my favorite stories to tell about why service level objectives make such a difference to your quality of life, and not just help you get alerted, not get alerted when things are not bad, but also help you get alerted in ways that your traditional monitoring would not catch. So in this outage, I happened to get alerted by our service level objective feature because it said, hey, you're burning through your error budget faster than you're allowed to. We were having a brownout. We were having 2% of our requests fail for 30 minutes at a time, and that would happen every couple of hours. And none of our traditional alerting went off because our traditional alerting relies upon 2 consecutive probe failures. With a 2% failure rate, the chance of 2 consecutive probes failing was almost nil. So we were not able to discover it with our traditional black box alerting. But with a service level objective based approach, our error budget started burning because we were measuring every request passing through our service. And we were able to get alerted, and we were able to remediate the issue fairly quickly. So we make data-driven business decisions. We think about, should I be engaging in more reliability or more experimentation depending upon the state of my error budget? And that's super freeing because it means that I no longer get paid if a dev runs an experiment as long as there's plenty of error budget left. And we're on the same page about which state we're in. For instance, I know that I can do a feature flag experiment on 2% of my users and have a 5-second rollback in case it goes bad, and that it's okay to do that as long as I have plenty of error budget left. Conversely, if I've had a set of bad outages, the error budget, rather than, hey, my team's gotten paged a lot, the error budget is the tool that I use to convince my product team that no, you cannot build new features when the service is on fire, because no one's going to appreciate how nice the features are if they can't trust the reliability of my service. So that's how we think about service level objectives and how we encourage you to adopt service level objectives in your organization. If you're interested in learning more, this is a little bit about Honeycomb. So Honeycomb is a tool that helps you understand your production services and have a look at what they're doing, whether they're meeting your service level objectives, and how to debug if your service level objectives are in danger. We're a complete observability solution that enables you to dig into all of these things at the same time, to go from measuring what is the target latency per event we're trying to maintain. For instance, that we're trying to serve results of telemetry sent to Honeycomb within 5 milliseconds per telemetry data point sent, that I can see how are we burning through our error budget, how are we doing? What population of requests is most prone to failure? Is it, for instance, one dataset ID? Is it one team ID? Is it one particular user agent? What are the varying factors that are happening that are contributing to the burn in my error budget? And if I need to, I can get alerted and know if I'm in danger of exhausting that error budget within a few hours. So we use PagerDuty to alert us only if the error budget is in danger. And when we do get one of those pages, we're able to pretty quickly figure out what's going on. We can go ahead and run a bubble up, for instance, just across the slow requests and have an understanding of what's separating those from the fast requests. And we can drill all the way down. We can drill all the way down into individual traces to see what's happening inside of our production systems. We can look at the data in the form of distributed traces, so we can see, is the problem that users are spending a lot of time before they send us complete payloads, or is the problem that our backend Kafka is being slow? Can we understand the shape of our data as far as the amount of time that each individual sub-request takes to execute? What's going on here? Why is it that this particular set of requests is getting particularly slow right here? These are all questions I can easily answer with Honeycomb. And this ability to go all the way from the high level of service level objectives all the way down into the low level of even being able to see raw individual rows of data, that's what's really powerful, and it enables me to spend my time making sure that my service is reliable enough for my users without necessarily having me getting woken up by PagerDuty every single day at 3 a.m. PagerDuty is a powerful, powerful tool, but it's really important to make sure that you are keeping your team happy, you're only alerting on what matters, and your developers and your operators are getting a really great night of sleep. So that's what I have to share with you today. If you're interested in hearing more from us, come stop by our booth. We encourage hearing your thoughts, and I look forward to sharing with you more about observability in the future. Thank you very much.